Okay, so a closed system is given and there are some, it undergoes a 2 or 3 process and heat rejection, heat additions and work done, all that is given. So what we do is we'll draw a table kind of a thing, okay, where we track all this in a process. So this is the heat, this is the change in internal energy, and this is the work done. Okay, and we do that for all the processes. So there are actually 3 processes. Okay, but before going to that, heat Q added to the system, remember system is the important thing, Q added to the system is taken as positive. Work done by the system, it's not on the system, it's by the system, is taken as positive. So work done on the system will be automatically negative. Work heat rejected by the system will be negative. So remember, these are the sign convention. Now the process 1 to 2, 100 kg of joules, it's a constant volume processes. So 100 kg of is heat the system receives, so 170 is added, so it's positive, and there is no work done actually because it's a constant volume. So increase in internal energy also will be 170, because how do you, for each of the process you can apply dq is equal to du plus dw. So dw is 0 because it's constant volume, so whatever heat is added, that increases the internal energy. Now process 2 to 3, work is done at the constant pressure, work is done on the system. So work is done on the system, it will be negative, so minus 40, and it says that the heat is rejected, so heat is rejected is also minus 70. So how do you get delta U here? Delta U, again apply the same thing, dq is du plus dw. So dq is minus 177 and du is something which you want to get, and this is minus 40. So minus 177 plus 40 will be minus 137. This is the decrease in the internal energy. So 3, 2, 1 now, going back to the same thing, you undergo adiabatic processes, so Q is 0, that is what is given, and we don't know anything else. So work done is what is asked, and we don't know U also. But remember that cyclic, when you are undergoing a cycle, the total change in internal energy has to be 0. So if you assume this is X, the total change in internal energy has to be 0. So 170 in the first process, minus 137 in the second, and plus X. So when you bring back to the system to its original state, the change in internal energy, which is a property, has to be 0. So this X will be 170 minus 170 plus 37, so it will be 43. Yeah, it will be minus 43. So because minus 170 or in fact, sorry about that, it is, let's calculate again, minus 170 plus 137, so it is 3 and 4, so minus 33 is the internal energy. So X is minus 33. Now applying first law for the third process, 3 to 1, so du plus dw. Now dq is dq plus dw. dq is 0 because it's adiabatic, so 0 is equal to change in internal energy we got from adding all that thing and setting it to 0, so minus 33 plus work done, so which is positive. So work is done by the system, work is done by the system, and it is 33, it's positive. So answer is 33. So what you do is, whenever the system is brought back to the original state, the sum of the internal energy, sum of the changes in the internal energy in all the processes has to be 0. So from that you get the missing cycle, the missing processes internal energy, then you can find out everything. So it's basically applying basics of thermodynamics. 33 kilojoules. Thank you.